it says the following diagram shows three quadrilateral, P, Q, and R on a grid. Please read instructions. Let me change back the marker to the regular. Now it says Q and R are images. Q and R are images, you know, not P, you know. Q and R. So what they're saying is, listen, this is an image. This is an image. All right?
And P will be the object, sir, to the original one.
Yeah, P is the original one, because they told you. It is the image of P. Of P. After it underwent two different transformations. So it's like you have your P and you do something to it and it turns into R. You have your P, you do another thing to it and it turns into Q. That's what they're saying. So two different things happen. It's like, no, two different things happen. So let us see what happens, what the questions are saying. It says here on grid on page 9, which is whatever. Draw the diagram of quadrilateral P after. So you're going to draw, so they're giving you work to do, you know. Draw the image of quadrilateral P, so they're sending you to do something after a translation by the vector 10, -4. You're going to do this now, you know. So what we want to do, so allow me to write what they said. Translation. So we're looking at this page here, so I could switch back and forth. All right, so, all right, I could switch, good. So we say now translate by the vector 10, -4, and we're going to call that P prime. So we're going to do a translation. So I'm going to write T equal to 10, -4, and when you get it, you're supposed to say P prime. So remember now, translation. We did translation. It's pushing something. So the top number. So now go back to our discussions of these things. This top number will either go to the left or to the right. If it is positive, it goes to the right. You could say that it's positive. It's positive 10. Look, it's a 10. So it's going to go 10 places to the right. This bottom numbers go up or down. But when it is negative, you're going to go down 4. So I'm going to go 10 to the right and 4 down and reconnect. I can do that. We don't have to do that, though, you know? Remember, we learned that if you have an object and you plus the translation, it's going to give you the image. So you see the coordinates? I could take the coordinates now. See them there? I could take them now and add matrices, and that is why it's good that you do matrices already. I could add matrices and we're going to see. So I'm going to do it 2 ways as quickly as we can because we want to maximize time and we have a lot to do. Right? So allow me to do the counting for those who appreciate the counting quickly. So we're going to go 10 places to the right and 4 down because of the numbers that we have. Let's go. So moving this point here, follow my lead. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the right. Then complete it by going 4 down. 1, 2, 3, 4. It ends up right here. Next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 down. 1, 2, 3, 4. It ends up here. Next one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 down. 1, 2, 3, 4. It ends up here. Next one. What? Let me change the marker because it's going to overlap. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 down. 1, 2, 3, 4. All right. So it ends up here. Everybody can see the point we're making? Let's follow the thing. So if you remember, as long as you remember, so positive goes to the right and negative goes to the left. Are we talking the top number? Because there's a different motion for top. The top number goes like this, left or right, and the bottom number goes up or down. All right? Positive goes to the right, negative go to the left. Positive go up, negative go down. We learn that. Do it now, man. Are you nice? Because the exam is not hard. It's whether or not you are actually doing your homework. You know? When I said homework, I mean, when the class is finished, you don't just leave it and you're gone. Oh man, you have to take some time out and go over your work. Let me do a nice diagram for you. I'm created the diagram. That's me trying to let you see something. All right, so you recreate a diagram and you're supposed to call this P prime. I want me to show you now just one other way or you could do your translation, right? I'm trying to maximize time as well. So watch this. It is also said that your translation, so make a note of this. Object for O, let me write it going that way. Object plus translation. Let me move this to. Just giving a second opinion. Option, should say, not opinion. Object plus translation will give you your image. I was talking about using the coordinates. So I'm going to pick on this. So if I should label up this diagram, this is -1, -3, -5, -7. You're seeing what's missing. So this point up here that I moved was -7, 1, 3, 5, 7. All right, so let us take a look. I think it is -7, 7. All right, good. This point is -7, 7 right here. This point here is a -7, +7. That point, just showing you. This point here is -6, 6. This point right here is -8, 6. And this one at the bottom here is -7, 4. See there? So what I'm saying, you know, you could take those points one at a time. Look. So that top point, -7, 7. If you want to add your vector to it, your translation, you have to turn it like that to match to the addition work. So I'm turning it like that because I want to be able to the addition to work. So you would have gotten 3, 3. So this is suggesting that this first point here, without doing the counting, I could add the translation and I am looking for the result at 3, 3. Looking for the 3, 3 this. Look, 1, 3, 3. You understand what I said? You could do it that way too. You could do all 4 points and just find your coordinates and connect. You don't have to do the counting. You don't have to do the counting as long as you have object. Come on, we're saying you can do addition. Addition. This is points. Yeah, man, it's add, you add. -7 plus 10 is +3. Remember, it's matrices you're adding. So top add with top. Bottom add with bottom. Straight. It's like it's a straight thing. Let us say you're taking the, let me just do one more. Say you're taking this at the side, -6, 6. -6 with a 6. Add that to 10, -4. Look, -6 plus 10, +4. +6 minus, is a plus and negative, this becomes +2. This point is going to be at 4, 2. Look for yourself. Isn't this 4, 2 right here? 4 meets 2 right there. See there? I'm just saying. See the 4 here? See the 2 here? See where they meet there? But I'm just saying, you have more than one option in the exam. Do the one you like. You get the point I'm making? I'm not telling you to do both. I'm just showing you that what if you don't like the counting? There's going to be another option. Take the one that suits you best. The next part of the question say, hey, do a reflection in the line y equal to 0. So I was suggesting that you have to bear in mind what this means. Y equals 0. Y equals 0 actually means the x-axis. Remember, a reflection is a mirror. So you're going count to the x-axis. And then the same units you get on the top is going to fall the same units beneath. For example, check this. This point is 1, 2, 3, 4 units on top. If this is a mirror, of which it is the mirror line. So it's going to fall 1, 2, 3, 4 behind. This point, count 1, 2, 3, 4, 5, 6. It's going to fall 6 underneath it. 1, 2, 3, 4, 5, 6. It's falling right here. This point, 1, 2, 3, 4, 5, 6 is a reflection, you know. It's going to fall 1, 2, 3, 4, 5, 6. It's going to land here. The next one, let me minimize this. So the next one, let me change the color. 1, 2, 3, 4, 5, 6, 7. It's going to fall 7 below it. 1, 2, 3, 4, 5, 6, 7. And you could see right there. So all you have to do now is to reconnect the shape with your ruler. So I'm just going to just do it quickly here with my little so-called lines. Do it already, Jay? There it is. They had asked us to put this in it. You put it in there. Anything they say, do it. Put that in there. So that's that. Now, there are follow-up questions now. Hold on, let me get bigger. Follow-up questions. This. They're asking you to describe fully a single transformation that maps P onto Q. P onto Q, you know, P onto Q, P. Look at P, look at Q. A single transformation that maps P onto Q, not the other way around. P onto Q. All right. So you want to know what happened to P so it turns into Q. Anybody want to quickly tell me what they think when you look at it? You realize one, it is an enlargement. Now, when you know that it is an enlargement, what you're going to have to do now is that you're going to have to find out things about the enlargement. Okay? So what it is you learn, that if you're going to describe, you can't just say enlargement and go on, you know. Whenever you're going to describe an enlargement, you have to do two things attached to it. One, you want to tell exactly. So you tell that it is an enlargement, that is okay, but you're not even there as yet. So you want to tell them that it is an enlargement. You need to tell the scale factor.
And the center.
And the center of enlargement.
That's all. That's all. So, and the center is a coordinate. That's all. Scale factor is a number, right? So all you're going to have to do now is to look. Sometimes you'll get some nice sides to compare, but it's not every time you'll see that. But you can take a look and see that, look at this. Would you agree that this, if we're comparing these two sides here, they are corresponding sides, true or false? Those correspond. True?
True.
Now you want to look. You can look at many things. How many diamonds did you see go across? Like, how many diagonals did this go across? One, right? One. Like it went across one box. And you realize that this one went across one more. So this one went across one box, and the image went across 3 boxes. It's giving you the answer already. You understand? So anything that link, you know, so this is telling you that the scale factor is 3/1, and you say, oh, this is 3. Yeah. Another thing you could look at this. I'm just showing you that with the scale factor, there are so many things to look for. You know that if you look at this distance here, if you can count it for real, how many I get? 2? Everybody, we get 2 right there? 2 from
Yes.
2. All right, I'm going to color the next one though. Watch this. The same idea for it. Corresponding idea. Count it and see if you now get 6 now.
Divide.
1, 2, 3, 4, 5, 6. We get 6. So you could say scale factor is equal to 6 over 2. And when you break it down, you still get back what? Still get 3. I am saying, learn this today, that whenever the scale factor is used, it affects every aspect, even things you're not thinking of. You might not be thinking of it, it affects it. So it's not every time they're going to give you vertical and horizontal lines where you can count. Look at this one. You would have had to count across to say, oh, okay, I'm seeing 1 box and then I'm seeing 3 boxes. I'm saying, yeah, 3 to 1. Okay. You could see a scale factor of 3 coming out easily, right? So that's not the big problem. Scale factor is 3. We can see that. Here's the next thing now. So let us put our scale factor. Scale factor is 3. Because it get bigger. So the scale factor was greater than 1. You know that already. To find the center of any enlargement, there is a specific concept that we discuss in class that, hey, you want to connect 2 pairs of corresponding, to color code them, 2 pairs, that's 1 pair, that's just 1. Here's another pair here. This could do the trick for us already. But for emphasis, I'm going to find all the 4 pairs here for the class. Here's another pair in green. And let me find another pair in another color, in another blue. There are 4 corresponding points. Now, if you should take any 2 and draw a very long line through them, they will meet at the center. It's not a maybe. They have to meet at the center. All right, so watch me. You'll take your ruler out. This is my ruler. Hey, boy. You take your ruler out. And here you go. Right there. Draw a very long line through it. All right? Hold on. My line disappeared for real. All right, let me go back for it. So I draw a very long line. We are looking for it. Huh? Is that bad? Let me change the color. Maybe a blue. See there? All right. So that's one. That's one line. So let's connect another corresponding. You know, the idea is corresponding is that anything corresponding. Watch this. So the moment you draw 2 corresponding, they are going to meet at the center. So already, this is the center right here. Now, I could just finish off the rest for you. It's 2 you need to do, but just for emphasis. Of which I don't really do in the exam, because I would have time issue. I've gone to another question. Corresponding. Everybody, you get yours already?
Yes, sir.
All right.
Yes, sir.
All right. So I'm not going to do anymore. I'm just showing you that. So I'm not going to do the 4th. They all, if you will see that, they're all going at the same place to cross up each other. All right. So that is how you locate the center. And then you read off now for them. This is where -10 meets, this was 7. That's the center. -10, 7 right here. Right? So you're going to just go back to your thing and you tell them that, hey, no, it's not difficult. It's just whether or not you are aware. It's about 3 marks. It's 3 marks to do this. So 1 to tell them it's an enlargement, 1 to tell them the scale factor, 1 to give them the center. You get 3 marks for this question. And you get 2 this and you get 1 more. 6 marks easily.